Our presenters are from the University of Hawaii Economic Research Organization, UHERO, and their work evaluates the economic cost and benefits of biological control efforts targeting three major invasive species in Hawaii: the coffee berry borer, the erythrina gall wasp, and fireweed. Their findings highlight how strategic investment in biocontrol can generate substantial long-term returns, both economically and ecologically. So today, first we'll be hearing from Conrad Newfield, a researcher with UHERO and the Institute for Sustainability and Resilience at UH Manoa. His work focuses on climate impacts and the economics of invasive species management. We'll also be hearing from Dr. Christopher Wada, an economist and researcher from UHERO, whose work includes groundwater and watershed economics, land use change, and invasive species management in island ecosystems. And we'll also be joined by Dr. Kimberly Burnett, a senior researcher and environmental economist with UHERO, who has led numerous studies on invasive species, watershed conservation, and the economic value of ecosystem services across Hawaii and the Pacific. With that, please join me in welcoming Conrad, Chris, and Kim from UHERO as they share their presentation, Cost-Effective Invasive Species Management, Biocontrol in Hawaii Delivers High Return on Investment. I'll hand it over to you, Conrad.
Thanks so much, Elizabeth. I'm really excited today to be talking about some research that we've done over the past few years to quantify these economic benefits. And with that, I'll go ahead and start. And then at some point, I'll hand it over to Chris and Kim to talk about their sections of this work. So the importance of this work is that there's really limited economic data on biocontrol in Hawaii. Our work is sort of the first to quantify the benefits of biocontrol in Hawaii. There's been other work elsewhere in the world that's shown really high returns on investment, but those are largely for agricultural crops across huge quantities, huge areas in large countries. And so our work hopes to provide evidence to support biocontrol investment in the future. We specifically looked at 3 case studies across different sectors. This was agriculture, ecology, native forests and culture, and ranching. Specifically, the invasive species that we looked at were the coffee berry borer, the erythrina gall wasp, and fireweed. And we used a 50-year time horizon for this study, starting with the date when the pest was first seen in Hawaii. So we use this benefit cost framework to quantify the benefits and the returns on investment for biocontrol research. In terms of costs, we have 2 different phases. There's the pre-release costs, which are largely made up of exploration, quarantine, testing, research. And there's the release costs along with the post-release, which would be monitoring subsequent releases, depending on the success of the biocontrol agent, and potentially other costs like permit renewal. The benefits are a little bit more difficult to quantify, and that's what made this work challenging in certain ways. One of the main categories would be the avoided management costs. So these are the costs that you avoid if you, in releasing the biocontrol, that you would have been that you're avoiding. Sorry, let me clarify that. So essentially, for some of these pests, we control them with chemical means, pesticides, insecticides, or mechanical control, depending on the type of invasive species. And so by releasing the biocontrol, you're avoiding having to spend that money, depending on the success of the biocontrol. And then, of course, there's avoided economic damages to certain industries. And one of the more difficult ones to quantify, especially in an economic sense, would be the ecological benefits to preserving certain species that are threatened by invasive species. So our analysis, sort of the economics of it, looks at three different components. The net present value. To do so, we look at all the dollars spent in the past and bring them into a 2023 dollar value for this work. And we project different costs and benefits in the future. And again, bring those back into 2023 dollars so we can make a fair comparison between the different costs and benefits. And then we have a cost benefit ratio, which tells you basically for every dollar spent on these biocontrol agents, how much benefit are you getting? And then a break-even timeline, which tells you how quickly do your benefits start to outweigh your costs. And just a note for this research, we use a discount rate of 2%. So here I'll just go over some brief hypotheticals. These were just drawn to demonstrate different potential outcomes for biocontrol release. So in this scenario, for example, you have some initial date where your costs start to accumulate, where a pest is spreading. And after, say, 10 years of research in this case, the biocontrol agent, the BCA, is released. And from there on, your benefits grow continuously. And at some point in this scenario, there's a break-even point. In this case, say 40 years. There's other scenarios, where maybe the biocontrol research took longer or the permitting process was delayed for some reason. And so your release might have been delayed. But this could also be a scenario where the biocontrol agent worked really well. And so the slope of your cumulative benefits line is steeper. And so it intersects with your costs sooner. And then there's also a scenario, where a biocontrol agent is not particularly effective and the two lines may not cross, at least within the 50-year time horizon that our work was looking at. And so now I'll hand it over to Chris, who studied the coffee bearer borer for our work.
All right. Thanks, Conrad. So starting with the coffee berry borer, also commonly referred to as CBB, it's recognized as one of the most economically harmful insect pests of coffee worldwide, causing damages in excess of $500 million annually. CBB reduces not only the yield of infested coffee farms, but also the quality of the coffee produced, which is especially important in regions like Hawaii that command premium prices due to the high quality coffee with unique flavor profiles. In fact, the $50+ million in value generated by over 7,000 acres across the state makes coffee one of the most economically significant agricultural crops in Hawaii. So on the left, you can see the CBB boring into a coffee cherry. It's the tiny black dot, so very small. And on the right, a close-up of a single coffee berry borer. Next slide, please. So CBB is native to Central Africa, but was first detected in Kona back in 2010. It rapidly spread to hundreds of coffee farms on the Big Island and then to neighboring islands across the state. Although data on statewide CBB infestation levels are not regularly collected, it has been extrapolated that around 94% of coffee-bearing acres in Hawaii were infested by 2021. And without management, some Kona coffee farmers have reported infestation levels of over 90% of their harvested crop. So all of these factors together suggest that the economic damages caused by CBB are likely very large in the absence of effective management, which leads us to the question of what exactly is current or status quo management. Well, in 2011, the fungus Beauveria bassiana was approved for use as a CBB insecticide on Hawaiian coffee. Spraying the insecticide in combination with other field sanitation measures like strip picking trees at the end of the season has resulted in observed reductions in CBB infestation levels. In the Kona and Kau districts, for example, average infestation levels at commercial farms fell from over 20% in 2015 to less than 4% in 2022. So you may be wondering, if the current management practices are that effective, do we really need a biocontrol agent? And the answer depends on how effective the agent is at reducing or eliminating the need for current costly labor-intensive management practices. Next slide, please. Hypothenemus coffea is currently being considered for introduction into Hawaii as a biocontrol agent for CBB. It's already been introduced in at least a dozen other countries, and lab tests have shown high host specificity, which is a good thing. And the final environmental assessment for the field release of pea coffee in Hawaii was approved back in 2023. But because it hasn't been established yet here, the effect of that introduction was not available for our analysis. So the benefit calculations are hypothetical based on the best available information at the time. And on the left, there's just a photo, a close-up of Hypothenemus, and on the right, you can see one of the wasps emerging from a CBB host after laying its eggs. Next slide, please. Okay, generally, as Conrad mentioned earlier, pre-release costs include those related to exploration, collection, quarantine, and testing, among other things. But this particular case is somewhat unique in that Hawaii obtained pea coffea for host specificity testing from Senecio, a coffee research center in Colombia. The state will also obtain wasps from Senecio in larger numbers for future field releases. So we don't include exploration and collection costs here. The pre-release costs do, however, include colony maintenance, non-target host screening, and a number of research grants that were instrumental for identifying a suitable biocontrol agent. But again, since pea coffea has not yet been established here, estimating post-release costs is challenging. We do not have a clear understanding of the likelihood of successful establishment, so subsequent release costs are not included in our analysis. However, post-release monitoring will be required regardless in order to better understand the effectiveness of pea coffea at controlling CBB. So we do include an annual monitoring cost through the end of the planning horizon. Next slide, please. Actually, sorry, can you go back? I guess I should say something about the benefits. On the benefits side, we focus on the avoided status quo management costs associated with CBB, particularly those related to the spraying of Bavaria throughout the growing season and strip picking at the end of the season. So ideally, the benefits would also include avoided damages to the coffee production. But we quickly realized that this would be challenging to quantify given the many other factors contributing to reductions in coffee yield and quality in recent years, such as coffee root knot nematode, coffee leaf rust, droughts, volcanic events, and on and on. So with that in mind, our benefit calculation should be viewed as a conservative estimate. Okay, now next slide. So moving on to the results, assuming a discount rate of 2%, as Conrad mentioned, the present value of all biocontrol pre- and post-release costs over the 50 years is estimated at $3.5 million. In the most optimistic scenario, which is our baseline case, the present value benefit, which includes the full avoided cost of both spraying and strip picking, totals $145 million, resulting in a net present value of $141.5 million and a benefit cost ratio of 42. Under the assumption that only 50% of the baseline benefits are realized, the net present value and BCR fall to 69 million and 21 respectively. And then in the case that only 25% of the baseline benefits are achieved, the net present value is estimated at 32.8 million and the BCR at 10.5. Next slide, please. Finally, we can look at what is happening annually over the 50-year timeline. So cumulative costs increase rapidly in the early years as pre-release costs are accruing, and then largely flatten out post-release. Benefits do not occur until release, but add up very quickly. So even in the most conservative case, where 25% of the status quo management costs are avoided, which is represented by the gray line in the figure, the break-even point occurs within 2 years of release, which explains the very high estimated benefit cost ratio. So now I think I'm passing it back to Conrad to talk about the gall wasp.
Thanks, Chris. Yeah, so for my section of this project, I worked on the erythrina gall wasp, which the most severe effect of that, of course, was affecting the willy willy tree, which is our native erythrina species. This is a key species both in terms of native forests, but it's also very culturally significant as well too. This particular tree is in the Waikoloa Dryland Forest Initiatives area, which we were able to visit as part of this project. So the erythrina gall wasp was first detected in 2005, and it quickly spread statewide within 6 months to all the major islands. It not only affects willy willy, but it also damages and can kill other erythrina species, which some of those other species were used for windbreaks, but also in urban tree planting. So the photo on the left here demonstrates what the damage looks like from the gall wasp. It causes galls on erythrina species, and not just on the leaves too, but also on some of the flowers and some of the new shoots as well. And this can cause the tree to defoliate. And a lot of erythrina trees are already deciduous. So when they do put out their leaves, that's really when they're generating, they're doing a lot of their photosynthesis for the year. And so when these leaves are affected by the gall wasp, the tree is severely damaged and is either has less health or can, in many cases, die. So the photo on the right is the wasp that causes this damage. So once the erythrina gall wasp was first detected in 2005, exploration efforts quickly started. Hawaii researchers went to areas with high erythrina tree species concentrations in sort of in Africa, I believe Tanzania, and other countries nearby to look for potential biocontrol agents. So the two that I'll be talking about today are Eurytoma erythrinae, which was released in 2008 and has become well established, and A. nitens, I forget the full scientific name, but the final EA was done for that in 2023, but it has not yet been released. The reason for these two different agents is that Eurytoma is effective when there's high densities of erythrina gall wasp, because its larvae need to feed on multiple erythrina gall wasp galls in order to move on in their life cycle. And so when there's a lot of erythrina gall wasp, Eurytoma does very well. And so therefore it can also protect, or it does well in protecting areas where there's high densities of erythrina species or willy willy trees. But in areas where there's sort of more individual trees that are spread out, A. nitens does better because its larvae only need to feed on a single erythrina gall wasp in order to move to the next step in their life cycle. So that's why A. nitens has been researched and has been proposed for release. So in terms of the estimated costs for erythrina gall wasp biocontrol agent research, the exploratory work was around 120,000. Rearing and testing, the additional grants and research make up the bulk of the costs, however. And there's also been some release costs and monitoring. Most of the post-release costs have been in the monitoring because the release went so well. I don't believe there were any secondary releases for Eurytoma. And for anitins, we assume, for the purposes of this project, a similar success in release and a similar sort of rate of post-release monitoring. So the total estimated cost of the biocontrol program for erythrinae gall wasp was around 1.1 million. And this is our summary table. So again, the present value cost was 1.1 million. We estimate a present value benefit of 27.2 million, and therefore a net present value of 26 million, with a benefit cost ratio of 24 in this case. So most of the quantified benefits here are the avoided listing costs, which Fish and Wildlife estimates is around $800,000 nowadays. Just all the regulatory steps to get a species put on the to become federally endangered. But the bulk of the benefit that we estimate comes from the Waikoloa Dry Forest Initiative's revenue. They started it in 2011, and they're an organization whose nearly sole focus is on the willy willy tree. They have some other species like uhi in their forest, but they host, for example, a willy willy festival each year. They have many visitors. A lot of their sort of media and organization is based around this particular species. And so because of that, we're able to allocate their revenue essentially towards a benefit of the biocontrol agent. And we also project out their revenue over the remainder of the 50-year timeline. And so here's what those two sort of curves look like over time. We've already passed the break-even point here at this time, but the benefits we estimate to continually grow as the Waikoloa Dry Forest Initiative continues to bring in revenue. And some additional benefits that we were not able to quantify in economic terms for this study were just simply the preservation of a really important species. The dryland forests have been severely reduced in their extent as and there's a lot of avoided insecticide use. This is not necessarily beneficial in terms of health because this is mostly neonicotinoids that were injected into trees, but that's just a cost that was going to be that was proposed and was being used in nurseries and in urban forests, but is now avoided because of the release of the biocontrol agent. As mentioned, Willy Willy has really high biocultural value. It was used in AMA for canoes, used for surfboards, used for lei. It's in the Hawaiian creation chant, for example. So it's a really important species. And perhaps the most important benefit of the erythrinae gall wasp biocontrol project was that it really changed the narrative in the public space around biocontrol in Hawaii. As we all know, there's been some pretty notable failures in biocontrol, ones that were released 100 years ago. Of course, in the past 50 years, biocontrol has been really successful with very few, if any, non-target effects. But the erythrinae, the success of the biocontrol and controlling the erythrinae gall wasp and how quick it worked really gave a lot of positive PR to biocontrol in Hawaii. And with that, I'll hand it off to Kim to cover her part of this project.
Hi, everyone, and thanks, Conrad and Chris. Before I get into fireweed, I wanted to just pause because I noticed there's a couple folks in the participant list that I would just want to acknowledge because actually just to give a little like background on this project, it wasn't actually our idea at all to look at this particular question. So Layla Kaufman and Mark Wright, who are both with us today, and also Mohsen Ramadan and Abel Conan approached actually Chris and I probably over 2 years ago because they were putting a paper together on kind of the successes of biocontrol in Hawaii. And as Conrad mentioned, there's not actually a lot of data on that. We kind of know anecdotally that we've had these major successes in Hawaii and they've been written about and documented, but not so much from the economic perspective. And so the evolution of the project was that they reached out and, kind of explained what they were working on and said, we'd really like to include the economics of this question in our paper, and would you like to join us? And so Chris and I said, that sounds really interesting, and what should we do? And we quickly kind of realized, as both I think Conrad and Chris have pointed to, it's not that easy to kind of calculate actually. The costs are not too bad, because we have a lot of data on research and, expedition costs and looking into, finding the right agent. But the benefit side is really tricky, because a lot of times we're talking about the bad things that didn't happen and what are the costs of that, and then interpreting that as damages or benefits. And then, with the gall wasp that Conrad just talked about, there's all of these cultural and kind of ecological benefits that are really hard to monetize. So we kind of came back to Layla and Mark and said, well, this might take longer than we thought. And also we're not sure, that we have the resources to actually do this. And so long story short, we ended up applying for a HIS grant with their kind of guidance about which species would be good to represent and look at, kind of looking at, like Conrad mentioned, a lot of different industries, but also kind of the timing. So fireweed, we're going way back to the 80s, it was found a long time ago, many decades ago, where something like the coffee berry borer is much more recent, as well as the gall wasp. So with their help, we kind of chose some species that we felt were representative of some of the successes in Hawaii. And so thank you, Layla and Mark, for spurring on and also supporting this research. Okay, so back to fireweed. So it was first detected in around 1980. It's on something like 400,000 acres now. I've seen different estimates that it was on over something like 800,000 acres before. This is a daisy-like weed from Madagascar. It's very prolific. So 30,000 seeds per plant. The viability, stays around for a long time, which also makes it a little bit difficult to assess in terms of how effective the biocontrol has been on fireweed, because these seeds are viable for something like 50 years. And so, just because we still have fireweed doesn't mean that the moth that was introduced has not been successful. So we'll talk about that in a moment. So in around 1999, and I'll show you a timeline in a moment, we started exploratory research for a biocontrol for fireweed. And so went to the exploratory entomologists went to Madagascar, South Africa, Australia, so the native range of this plant. Brought back a lot of insects, a fungus, and eventually settled on this Senecio extensa moth that was eventually released in 2013. And I just realized, as Chris and Conrad were presenting, that we don't have a picture of this moth anywhere in the presentation. So sorry, that's a very typical economist slip. Like, we're really bad at photos. So the problem with fireweed is it competes with forage grasses that cattle depend on, reducing some estimates feed availability by 15 to 40%. So, for something like a horse, fireweed is poisonous. It's very dangerous and can really get a horse sick or even kill them. We talked with Mark Thorne about fireweed probably the most, also Layla and Mark Wright, but he had a lot of funny stories about trying to feed cows fireweed, like putting them in, an area with just fireweed and just kind of waiting to see what would happen. And the cows absolutely hated it. At some point they were forced to just eat it because they had nothing else, but they were spitting it out. And Mark was telling us, cows don't really spit. And so seeing them kind of like try to get it out with their tongue was very telling that they did not want to eat the fireweed. So they really avoid it, which can reduce herd size and productivity for cattle ranching. Next slide, please. So this is just the timeline I've briefly talked about. So introduced around or discovered around the 80s. Exploration and testing phase was between 1999 for about 10 years. So doing field surveys, host specificity testing, and collecting overseas. The permitting, rearing, and kind of prep approval process was 3 years, 2010 to 2013, and then finally released in 2013 on Haleakala Ranch on Maui. So starting on Maui, but also some subsequent releases on the Big Island. And then we include some monitoring costs as well. These have been a little limited, and this was hard to kind of find exact estimates for, but there have been some monitoring efforts since release. So our timeline again is 50 years from kind of when we have the first data point in terms of like when we started looking for the biocontrol agent. Next slide, please. So our estimated costs for the fireweed biocontrol are about 2.2 million, and that includes just, publicly available data on the exploratory entomologist's salary, also some travel assumptions about how much, all of these international trips cost, collection, rearing, testing. We also at have access to the Office of Research Services database, so we can look up any kind of related grants and research, not only on fireweed, but we actually did this for all of the species for CBB as well as the gall wasp. So just looking into, if grants were given to look into these different non-target effects or just kind of pre-release expenditures. And then we have assumptions about post-release monitoring after 2013. So estimated total program for fireweed biocontrol is about $2.5 million. Next slide, please. Okay, and then of course the tricky part that we always struggle with is the benefit side. But of course, this is the main focus to kind of making the argument that biocontrol is a good investment in the long run. So as far as fireweed, there's kind of two things. I already talked about the cattle. And so if cattle are readily avoiding fireweed, you're going to get some loss in productivity of cattle production. And while not a huge part of the agricultural economy, it's significant. It's something like $40 million a year. And so we looked at, what's the total pasture land acres statewide and the infestation of fireweed across that land, and using the total value annually of cattle, we kind of, and this is a big assumption, we understand there's different types of cattle, locally finished versus cow cattle and that kind of thing, but kind of thinking about, can we think about a typical acre and what the cattle value would be? It's something like $55 an acre in 2023 dollars. And thinking about, if you're going to lose 15 to 40% of that because of the fireweed, you can potentially avoid that loss. And it's something like $9 to $24 million annually. So that's only in kind of protecting the cattle industry by having an effective biocontrol for fireweed. On the other hand, we've talked about chemical treatment as kind of another option rather than using a biological control agent. It's not really practical to think about doing chemical treatment of fireweed because it's just so widespread in Hawaii. So we looked at what has been done actually, and there have been like small treatments using chemicals of fireweed, but we're only talking like 5 to 10,000 acres. So these avoided management costs are smaller, much smaller than thinking about protecting the cattle industry. But we wanted to try to be as complete as possible. So that's something between $200,000 and $400,000 a year, depending on how large of a scale we're controlling. Next slide. Okay. And so this is all similar tables and graphs that you've seen before. So the present value cost is always the same. Again, it's just that pre-release and release cost of about 2.5 million. So that's relatively small for fireweed. You know, Mark Thorne was also telling us all you need is a cage and some peanut butter and honey, and like, I don't know, I think he said like a 0.2 FTE. It's not a big expense to kind of get the moth going. And so on the benefit side, we had different scenarios depending on, remember we had like avoided management costs, but also avoided cattle losses. And then we had a range because again, this is all very uncertain. And so we had a range of low management costs, high management costs, or low avoided cattle losses, or high. And so depending on which one you choose to believe, the benefits are something between $5 and $24 million. And so we have a much kind of smaller benefit cost ratio than we saw in the previous two examples. But again, the cost was also relatively much smaller, right? So it's something between 2 and 9 as a benefit cost ratio. So smaller, but still a good investment, right? So we're still seeing higher benefits than costs in the end. And there's one more slide. That's the graph, the same graph you've seen many times. So we showed kind of the best case scenario. That's the green line with, we protected a lot of cattle value and also, avoided a lot of management costs, or kind of even in the worst case, we're still clearing, we still have higher benefits and costs, but they're, the slope is much lower. Like in Chris's slides, everything went straight up, right? The benefits are just huge. In fireweed's case, it's probably not that, but it's still, above the cumulative cost over time, which is what you want to see for an investment. And then I'll turn it back to Conrad to kind of wrap up. Oops, no, I won't. I have one more slide. One other uncertainty about Senecio was that there was a lot of variable effectiveness. So depending on where you are on Maui, we kind of heard from many people that it was probably more successful. One reason is because the ranches are kind of closer together. And so when the release happened, for one, everything was closer together. Two, there's housing developments throughout, kind of closer to the ranches. On the Big Island, you had this light problem. Remember, this is a moth. And so, if you're releasing Malka and, or Waimea, that kind of area, all the lights are kind of down in Kona, right? And so the moths were attracted to the lights and they would leave the ranching area. Whereas in Maui, you have neighborhoods kind of scattered throughout the ranching area. And so that's one idea of why it was a little more successful. Nobody really knows. The other thing that's a little bit different about fireweed is it wasn't so much, I would say, like a home run. There was a lot of, I think we've seen less fireweed over time, but it's a little anecdotal. So, anecdotal evidence of population reduction, but not too sure. The other thing about this moth is it really liked Cape ivy. And so we released a Senecio, and not only was it kind of flying downhill towards the lights, it was eating Cape ivy like crazy, which is okay. I mean, it wasn't a big concern because that's also a non-native species, but not really the target that we were going for. As I mentioned before, it has a really long seed bank. So kind of knowing if we're seeing real population reduction is hard because it's just viable for so long. So there's a lower certainty compared to the other two programs we discussed. Now I'll turn it over to Conrad.
Thanks, Kim. Yeah, so this is the summary table. You've seen a lot of tables, but this is the last one of all of our 3 different invasive species that we looked at. The one sort of new part here is the break-even point, which is shown on the graphs, but here we quantify it. So for coffee bear borers, about 1 to 2 years. Again, Chris's line said there's really steep slopes. For erythrina gall wasp, we estimate around 2 years. That's all it took to where the benefits start to outweigh the costs. And for fireweed, as Kim just talked about, it's a bit more uncertain. So there's a bit more of a range of 2 to 13 years, but still all of these do have a break-even point within our 50-year time horizon. Yeah, so in conclusion, we found consistent positive returns on investment for biocontrol agents in Hawaii, at least the 3 that we studied, albeit with varying degrees of economic efficiency. We find that building capacity for biocontrol research will likely yield returns for decades and centuries to come. Right, for this work, we only looked at a 50-year time horizon, but once, for example, with Willy Willy, that is assumingly the erythrinae gall wasp is taken care of for a very long time. You're going to have Willy Willy trees for forever, hopefully, as long as there's not some other threat. And lastly, one thing to note here is that biocontrol is a really important management tool because it frees up resources for other invasive species that you may not be able to control with biocontrol. For example, things like LFA or coqui frogs. So it's really important to invest in biocontrol where we can, because there are many other species that have not many options for control. And yeah, so we'd like to thank Hawaii Invasive Species Council for hosting us today and for funding this work. Layla Kaufman, Mosen Ramadan, Mark Wright, and Abel Conan for helping craft the original study. And as Kim mentioned, I'm glad some of them were able to join today. And the list below there too of folks who hosted us for interviews and field visits. This is really a fun project. So now we'll turn it over to Elizabeth.
Mahalo. That was an incredibly interesting look from a different perspective that I'm used to on these biocontrol agents and that kind of cost benefit analysis that was going on. You're getting lots of claps. Hopefully you can see that too. And I just want to invite everybody that is here with us live. If anybody has questions, I don't see anything in the Q&A. But if anybody has questions, I think that my colleague Chuck is, we see one question. So I'm going to invite my colleague Chuck is going to help with the Q&A portion. And I have a question too.
Hey, Elizabeth, since they're, a relatively small, modest number of participants, I would invite the questioners to unmute their mics, turn on their videos if they'd like, and ask their question directly. So Mark Wright, I see your hand up. If you'd like to ask your question, please feel free to do so.
Yeah, thank you, guys. That was great to hear. I'm really pleased that this all got done, and it's super useful for those of us doing biocontrol. I just wanted to ask you planning to publish this in a peer-reviewed journal, one of the biological control journals, perhaps? I think that would be a really valuable contribution.
Go ahead, Kim.
Yeah, absolutely, Mark. Thank you. I think we had gotten stuck. We definitely intend on it, but we would like to actually talk with you about where you think is appropriate, because we definitely want to get it peer reviewed and out there. So
Great. Yeah, happy to talk to you about it anytime.
cool. And thanks for all the information and thinking of this project.
Yep. Layla too.
Yeah.
Go ahead, Rob.
Yeah, thanks, Kim, Chris, Conrad. Great work. Exciting to see your results after working on it for a few years. I was just wondering, in the interim before it's published, is it possible to cite your results? Especially, I'm thinking, as we're requesting additional funding to support biocontrol capacity. I think this is really key information for decision makers. And would it be possible to cite this as unpublished data or in publishing?
Yes, actually we have, and I can put a link in the chat. We have a report on the UHERO website that is already citable and linkable that I can send you, as well as a kind of easier to digest with way less words and dollar signs and tables blog about the topic. So I'll put both of those in the chat.
Fantastic, thanks.
Thank you.
Elizabeth, you're up.
So I was curious, just within the context, and I don't know if this is something that you guys know offhand, but a lot of these terms, like the benefit cost ratios, like the specifics of all of this is fairly new to me. And I was wondering if you guys have any knowledge of how these biocontrol cost benefit ratios might compare to other analysis of cost benefit for other conservation public investments that you have looked into or are aware of.
I can jump in, and then if Chris or Conrad want to. So I think for biocontrol, they're in line, if not on the low end. We've seen really kind of big benefit cost ratios in the biocontrol space. I mean, we should also say that I'm not sure that really represents all of the failures as well, right? Because people aren't going to, I mean, we chose a species that we are kind of looking for a specific message, right? So nobody is doing the one on mongoose or other ideas. As far as other kind of conservation investments, I think they're quite good and quite much higher. A lot of the work that Chris and I have worked on a long time, and Conrad more recently, has been kind of on watershed conservation. And you're never going to see like 50 to 1 as far as benefit costs, because fencing and watershed protection is very costly over time, and especially initially, right? And so is biocontrol. But at least in Hawaii, and I'm not sure if that's true globally, but for sure, I think biocontrol has much larger returns overall than something like watershed conservation. But again, that may not be true overall.
Yeah, I want to say that we maybe cited a survey or a meta-analysis on sort of benefit cost ratios of different biocontrol programs globally. I know I've seen something because I feel like we looked at a table of it, but I can't promise that it's in the report, but we may have it a link to that in there somewhere. But yeah, as Kim mentioned, as I recall, it seems to be quite high in general for biocontrol, I guess, although yeah, I don't know how it compares necessarily to other types of conservation management tools or approaches.
I don't see any other hands up at the moment. So I do see one from Mark Wright. Mark, please go ahead.
Sorry, I was just belatedly commenting on that question about the costs relative to other conservation management. I think from South Africa, over the years, there have been quite a few comparisons of costs of regular, like weed removal, invasive weed removal versus biocontrol. I can try and dig them out if you guys are interested. It was just a comment.
Yeah, that'd be great. I do think we've seen them, like Chris said. I just don't remember if it made it into the final report, but when we write up the peer-reviewed publication, we'll definitely be pointing to those as well. But I do remember seeing tables and thinking, wow, it looks like a great investment in many, many places. So yeah.
Cool.
Yeah, I just was able to pull up I think the table that I remember finding, and it was the crops here were like cassava, mango, banana, cabbage, and corn. So big crops that a lot of people rely on. The benefit cost ratios are all over 100 to 1, and one of them just says greater than 200 to 1, because like millions and hundreds of millions of people rely on these agricultural products. So
Go ahead, Pat.
So I see these summary of values. Is there a breakdown as far as maybe like a per acre, cost benefit? Because I think that might be useful for, people who are, ranchers or farmers who want to, understand how much, this biocontrol might be, worth to them.
That can definitely be done for fireweed, because part of the assumptions that we're making are that things are uniformly distributed, which we all know they aren't, but just on average, yeah, we could break things down by acre. That might make it a little easier to think about as far as like management costs per acre versus benefits. Yeah.
Right. Yeah. Because, that would make it, accessible to normal everyday peoples.
Right. Yep.
I think, yeah, that could probably work for the coffee too. I mean, I know it's 7,000 something acres, but that's including small family farms and stuff. So if you really want to get into it, I guess we'd have to look at sort of the distribution of the types of farms, since it's probably a lot of commercial farms that are going to benefit, on the larger scale, I guess, from something like this.
Yeah, I mean, it's not going to be an easy thing to do, but I mean, just kind of giving people a ballpark would be helpful for our discussions, I'm sure. So.
I have one question if there's no other ones. I was just curious. I know that one of the major costs with the evaluation of the biocontrol is the non-target testing, and in the benefit column you get avoided management costs from the impacts of the invasive species. And I seem to recall like a recent publication where they were talking about maybe some of the testing and delay with the release of the biocontrol agent has overcompensated on the avoiding risk side. Maybe that some people are arguing that the process should be streamlined so that things are released more quickly. I was just curious, is in the non-target host testing, an avoided cost could be avoiding accidentally harming a non-target host or a beneficial native plant or an economically important plant. So is the host range testing cost, is it ever given a discount in these types of analyses for avoided future unintended consequences, or is that not considered a significant part of the overall cost benefit analysis? Does that make sense?
I think I know what you're asking. I mean, I guess the issue is the argument is kind of now that it takes so long just to get anything approved because you're having to show that you're going to have all these non-target impacts, right? And making sure, and so it takes 10 years for approval. So I think what you're saying is, those costs are important because we're making sure that we don't lose, an endangered species or something that we didn't intend to, when we release the biocontrol. So let's see, if we were even more careful, that would make the cost side go up, right? I mean, the interesting thing about the argument that we need to streamline is even with 10 years of research and non-target testing, you still have a very high, return. So the only thing that streamlining would possibly do is make, you have less years of testing, right? So your cost maybe goes down by a third or a half or something. So you save, but from this analysis, you could say, well, we know it's not streamlined and it's tedious and there's all these requirements, but it's kind of worth it, right? So that's kind of built in because look at the benefits that are coming. And so I think our study could actually kind of dampen that and say, I see what you mean, because you would almost say look how important this is. It's this huge ROI. We should hurry up and do it. But actually, no, because just spend money, the benefits are so high, let's be sure, because the cost of losing something, we don't even include in here. And, the benefits are really high. So yeah, this analysis is always hard because the benefits are kind of opposite of what we think. It's the avoided losses. We don't get a benefit from bringing in a moth to kill the fireweed. We get a benefit from bringing it in so that the fireweed doesn't do harm, right? So this is why there's not a lot of economic analyses of biocontrol in Hawaii yet, because it's a little tricky. I don't know if I answered your question, but.
You did, thank you.
Okay.
Yeah,
bureaucracy takes time.
I think that we've come up against at the end of our lunch hour. So I wanted to kind of wrap things up and give you guys all a reminder that this presentation was recorded and streamed to YouTube. It is available immediately if you want to share it with others. And this HISC Brown Bag series is held regularly or semi-regularly to highlight research and innovations supporting Hawaii's biosecurity invasive species management efforts. You can keep track of what HISC Brown Bags presentations are coming up on the HISC website and by signing up for the HISC email list. And finally, I wanted to mahalo nui our presenters, Conrad Newfield, Christopher Wada, and Kimberly Burnett from UHERO. Mahalo for sharing your time and your research with us today, and to everyone that joined us live, as well as all of you who have watched this video to the very end. So mahalo nui and a hui ho.
Thank you all.
Thank you.
Thank you.